In this video, we're going to see some examples of binary arithmetic with signed numbers, specifically with ones complement and two complements. So first we're going to start with the addition using ones complement. So we start with positive 5, 0, 1, 0, 1, and plus positive 2, 0, 0, 1, 0. And we end up with a positive 7. So in this case, it works and it's correct. Now when we have a negative 5, and remember we're using ones complement, if you've seen in a previous video how to convert a binary number, negative binary number, using ones complement, we can see that we need to invert each bit of the positive plus 5. Then we also have 0, 0, 1, 0, and we add these 0 plus 0, 1 plus 1 equal 2, which in binary have a 0 and we carry 1, then a 1 and a 1. So using the conversion of a binary ones complement number, we can tell this is starts with a 1, so that's a negative number. Then we invert each of the bits, so 1, 1, 0, and 0, and that's a 3. So we have a negative 3. So in this case, it also works. Let's see the next two cases. Positive 5, have 0, 1, 0, 1, and negative 2. Again, we need to convert from the positive 2, we invert all the bits. So 1, 1, 0, 1, 1. And then we add, see, 1 and 1, that's 0, we carry 1. 1 and 1, that's 0, and we carry 1, 0, and we carry 1. We finish with one more bit, so what do we have to do with that one? Okay, so one of the possible cases is that we put it here, we just add it to our results. So we have a 1, 1, 0, 0, which gives us a positive 3. For the last case, we have a negative 5, 1, 0, 1, 0, and negative 2, 1, 1, 0, 1. We add those two. We also end up with one more bit than the 4 that we started. And what can we do with that? In this case, one option is also adding that one. 1, 1, 0, carry 1, 0, carry 1, 0, carry 1. Okay, so 1, 0, 0, 0. So that's a signed number. That will be a negative, and then we invert all of the bits, so 0, 1, 1, 1, which is the negative 7. As you can see, it's not very simple. A correction is needed sometimes, okay? Sometimes it's needed, sometimes it's not needed. The top scenarios, we don't need to add the extra bit to the result. What about the case with 2's complement? So we're adding 2's complement binary numbers. So positive 5, 0, 1, 0, 1, and a 2. We just add those two. They're positive numbers. We don't need to do anything to that. So in this case, it's correct. What about the negative 5? In previous videos, you have learned how to convert how to represent a negative 5 in 2's complement. In this case, we start from the right to the left, we copy the first one, and then we invert all of the rest. Positive 2, 0, 0, 1, 0, and then we add 1, 0, carry 1, 1, and 1. Okay, in this case, we have to check if we end up with a negative 3, and the first bit tells us that's a negative number, and then we convert this 2's complement binary number into decimal by first going from right to left and copying the first one, and then inverting the rest. 0. In this case, you can see that 0, 0, 1, 1, that's a 3, so we have a negative 3. So in this case, it also works. Plus 5 plus minus 2. So we have a 0, 1, 0, 1. Minus 2. We copy all of the zeros starting from the right. We copy the first one, and then we invert then we can add 0, we carry 1, and then 0, we carry 1. So in this case, we can ignore the first bit, and we end up with a positive 3. What about this last case? We have 1, 0, 1, 1, and we also have a, where is it, 1, 1, 1, 0 for negative 2. We add those 1, 0, 1, 0, 1, and a 1, 1. We can ignore the first bit, and the rest we start with this bit. So that's a negative number, and then we do the same converting to decimal. So 1, 1, 1, 0, which is a 7, which gives us a negative 7. So in this case, the 2's complement addition also works. In other cases, we can ignore any extra overflow bits. What about subtraction with 2's complement? We saw that addition always works with 2's complement, so let's check subtraction. Okay, so how do we subtract? So first we have to get the complement of the subtrahend, and then we can add it. You can see that is the same saying plus 5 minus plus 2 as saying I'm gonna have a plus 5 plus minus 2. These two are equivalent, correct? So if we follow that, we have a 0, 1, 0, 1, and then we get the 2's complement of the 2, which was a, let's see, let me do it here on the side. So I have a positive 2, 0, 0, 1, 0, and then 2's complement, that will be a 0, 1, 1, 1. So 1, 1, 1, 0. And then we add those two. That's a 1, 1, 1 and a 1, 0, 1, 0, 1. Okay, so remember we ignore this bit. And what is this number? So remember this is 0, so that's a positive. And then this is a 3, so positive 3. So it works. What about this other example? So minus 5, we're going to have a 1, 1, 0, 1, and a negative 2. Remember we had a positive 2, but we're going to do the 2's complement of the subtrahend. So we have a 1, 1, 1, and a 0, and then we add. So 1, 0, 1, 0, 1, 1, 1. We ignore this one. We have this is a negative number. And then we do the shortcut conversion to decimal. So 1, 1, 1, 0. Okay, so that's a 7. So we have a negative 7. So in this case, we also see that subtraction of 2's complement also works.